NCM Learning Center. Good morning friends. In this video, I am going to explain about Thevenin's resistance calculations for the various types of problems. Mainly three types of problems are there. The first type is if the circuits have all the sources are independent source, then we have to follow some methods for the Thevenin's resistance calculations. The second case is suppose in the circuits at least one of the source are dependent source, then we have to follow the other Thevenin's resistance method. Okay. Third case is if the resistance is infinite series, definitely you have to follow the different types of Thevenin's resistance calculation methods. So now we will discuss the various methods of Thevenin's resistance calculations for the all the type of problems. Okay, first we will discuss case 1 problems. If in the circuits all the sources are independent sources. Independent sources means the source value is does not depends on other values. Here is a voltage source 5 volt that is not dependent with other values. Here 2 volt is a 1 amps current source. The source all are independent source. Okay. If the given circuits are independent source, you have to follow some methods. Thevenin's equivalent resistance is defined as the total resistance appearing between the two terminals, mainly load resistance in the given circuits with all the independent sources are turned off. Okay, turned off means we have to make 0. If we short the voltage source, the value will be 0. If we open the current source, the value will be 0. Okay. Method 1, network reduction method. But based on the definition, the first step is we have to turn off all the independent source. We have to short the voltage source and open all the current source. Now the circuit will become like this. Here this is short, the branch is open. If any branch is open, we may remove the branch because there is no current flow through the branch, there is no effect on the circuits. So we may remove the branch if the branch is open. Okay, here the branch is removed. The second step is we go to find the total resistance appearing between the load resistance. So we have to remove the load and assume current flow from the load. Okay, so now the circuit will become like this. Important point is we have to assume the current flow from the load. Okay, so the current like this. Now find the total resistance by using the network reduction method. Here the current is there. The current is divided into two parts. This part is depends on the 10 ohm resistance only. This part current is depends on the 10 ohm resistance. So this 10 ohm resistance and this 10 ohm resistance are parallel. Okay, so we use the parallel formula. 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Otherwise R equivalent is equal to R1 R2 divided by R1 plus R2. Here R1 is 10 ohm, this 10 ohms, R2 is this 10 ohms. So the value will be 5 ohms. Okay, if the two resistors, equal resistors are parallel, then the total resistance will be divided by half. Without substituting this formula, we have to tell the answers. Here 10 ohm parallel, both are same, so halfly divided, so 5 ohm resistance. Okay, when you are going to write examinations, you should answer very quickly. Okay, without using this formula. Then this 5 ohm resistance are series with the 10 ohm resistance. The total resistance will be a 15 ohms. So Thevenin's resistance is 15 ohms. Some of them wrongly will calculate that this 10 ohm are parallel, but this 10 ohm not parallel, because this current is divided by 2, this branch as well as this branch. So this branch are parallel. If any one of the resistance is like here in series with the 10 ohm resistance, then means the total branch is parallel with this branch. So we go to first the total branch resistance, then total resistance is parallel with the 10 ohm. Okay, refer the network reduction method. The method is suitable only if the circuit have all the sources are independent source. If any one of the sources are dependent source, then we cannot use the network reduction method. If you use the network reduction method, if the circuit have dependent source, definitely your answer will be a wrong one. Okay, now we will discuss the second method, 1 volt source method. Okay, based on the definition, we go to turn off all the independent source first. Short the voltage source, open the current source. To find the total resistance appearing between the two terminals, instead of using network reduction method, I am going to use 1 volt source here. I am going to place 1 volt source here. Next, I will calculate the current, total current. Total resistance will be V by I. Okay, so step 2 is replace the load by 1 volt battery here to find the total resistance. Okay, now the circuits will become like this. Voltage source shorted, here the voltage source shorted, current sources are open, so the branches are removed. The load resistance replaced by 1 volt battery. Next step, I am going to find the current, total current out from the source, I value. We may find the current I value by using mesh analysis or node analysis. For the given circuits, the current I is equal to 1 by 15 is equal to 0.0667 ampere. Next, I am going to find Thevenin resistance R is equal to V by I. Here V is 1 volt directly given, so I is equal to 1 by 15. So the answer will be 15 ohms. For the method 1 and method 2 answers, both are same answers. Okay, but this method is suitable for any circuits. Maybe the circuit may be a independent source or a dependent source, any type of circuits. The method is suitable. Also, the method is easiest one. Okay. Third method, short circuit current method. The step 1, we go to find the open circuit across the two terminals, maybe the low terminals. Now the circuits will become like this. For these methods, no need to turn off the independent source. So, okay, the second step, we go to find the short circuit current. Short the load and find the short circuit current. The step 3, Thevenin resistance will be RTH is equal to open circuit voltage by short circuit current. But this method is somewhat harder than other methods, method 2 and 1. Conclusion, if the circuit have all the sources are independent sources, then use method 1 or method 2. Method 1 and method 2 both are easiest. Okay, we may use any one. But if the circuit have at least one dependent source, use method 2. Don't use method 1. If the open circuit voltage and short circuit current is given, directly given, then only use the method 3. Okay, this is the conclusion. Next, we will solve another one type of problems. Here, in the circuits, all the sources are independent sources. So, based on the introduction method, the step 1, turn off the independent source value, short the voltage source and open the current source. Now the circuits will become like this. Shorted is open, so we may remove the branch. Step 2, remove the load, assume current flow from the load. Now find the total resistance. Here 3 ohm shorted, so all the current flow from the short circuit path. There is no current flow towards the 3 ohm resistance, so we may omit the 3 ohm resistance. So we may directly write, or otherwise, if the branch is shorted means the resistance is equal to 0 ohms. This 0 ohm resistance parallel with 3 ohm resistance. So total resistance R equivalent is equal to R1 R2 by R1 plus R2. R1 is equal to 0. We are shorted. R2 is equal to 3 ohm. You will get 0 ohms. Okay. Without formula, we go to write directly. Okay. Here there is 3 ohms shorted directly, so the net resultant will be 0 ohms. Okay. Then 2 ohm and 3 ohms are series, so the total resistance will be 5 ohms. Some of them wrongly write that without considering the short circuits, so the total resistance will be 8 ohms. That is wrong one. Okay, we go to consider the short circuits. If any resistance shorted, the net result will be 0 ohms. Okay. Next, for case 2 problems, if any one of the sources is independent source, we may discuss in the next video. And also, if the circuit have infinite series, we will how to calculate the Thevenin's resistance calculations. We will discuss in the next video. Okay. Now for do it yourselves. I listed question 1, 2, 3. We go to find the Thevenin's resistance. Try and comment your answers. Wait for the next videos. Thank you. Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.